Well, hello everyone. Today we're going to talk about inheritance. Now, this concept is very important in object-oriented programming, and today we're going to learn about the details and what it is and how does it work. Inheritance basically presents a type of relationship between classes. We already talked about the composition relationship, and we said sometimes you can create a class where a data member or a member of that class is an object of another class. So we describe that relationship as an object of class A and I want you to put lines under the word has an object of class B as a member. And that's what composition was all about. Now, today we're going to talk about a different types of relationship, which is inheritance. Now, before we get into the inheritance and the technical part of it, it's really important to understand why do we need it. Basically, and I want you to imagine this scenario. Let's say you have a project, and in this project you are going to create, let's say, 10 classes. At a certain point, you realize that there's like 5 functions and 5 variables, and each one of those classes is exactly the same. Same 5 variables in each class, in addition to extra more that will make each class different than the other. But you notice that there's 5 variables are repeated in every single class, and there's another 5 functions are repeated in every single class. So basically, declaring those variables and defining those methods inside each class by itself, it's considered redundant, repeating the same code over and over and over in those 10 classes. So what we'd like to do, we can create a new class. We can call it whatever you want to call it, and you can put the declaration for those variables and the definition of these methods all in that class. And then what do? You make all the other classes inherent from that new class that you created. So you just type and you define and you declare all these methods inside that new class and make all the other class inherent from them instead of just repeating the same code in each one of them. And that's basically what inheritance is all about. It's a way or a method that we can save some lines of code, and we will not need to redundant and repeat the same code over and over. And that's one of the benefits. Now, usually, this is again not necessarily the only case, but usually whenever you think about inheritance, you will have what we call a base class or a super class. Well, every single programming language, by the way, they like to call them in different terms, but they're exactly the same thing. So in C++, basically, they call it the base class. In Java, they call it the super class. Again, let's talk about C++ here. So the base class, people like to think about the base class as a more generic class, not a very, very specified class. And then you have other classes which we call the derived class. And those derived classes are very, very specific cases of that generic class. What does that mean? For example, if I want to create a simulation for a zoo, what I can do, I can create a class called animal. And in this class of animal, I will just define everything that an animal would do. And then after that, I can create other classes, let's say cats, dogs, lions, elephants, fishes, uh, hyenas, whatever the animals I want to create. I can create other classes, which are going to be called, those are going to be the derived class. Now, if you think about it, let's talk about dogs and cats, basically. There's a lot of similarity between them because both of them are animals, and both of them would do whatever the animal would do. So instead of me repeating, for example, a method of moving for the dog and another method for moving for the cat, and where I know they both use the same mechanism of moving, I can create one method called moving inside the base class, which is the animal class. And then after that, I will just inherit from that animal class, so both of them will be able to move exactly like any other animal will move. So those are basically just examples, but again, there's a lot of technical details that we have to understand when it comes to inheritance, but I'm just trying to show you an idea about what is inheritance. So in general, whenever you have a case where you know I'm going to create multiple classes, and those classes basically And basically those classes, they have some sort of similarity. And instead of me repeating the code for each one of them, I can create a base class, and then let them all inherit from that. Or sometimes you have a scenario where uh, it makes more sense to create a base class for a specific data type, and then for a more generic data type, and then after that you create classes for specified objects, and make those specified objects inherent, or classes inherit from that base class. um, and that's basically what inheritance is all about. So let me see if I'm missing anything, what it is, why it is, and how does it work. Okay, now let's have a look at this example here. So of course, as I said, there's a lot of details that we need to understand when it comes to inheritance, and I'm going to go through them in this example. Number one, I do have a class. I call it class A. In class A, I have a private data type, which is X. And now in the public section, I have the constructor, two of them, and then I have the destructor, and then I have the void print method, which basically going to print the name of the class and then the value of X. And then I have a method, it's called test class A, and basically it's just going to print the test method. This again here just to demonstrate how does it work. I got another class called class B, which is very, very similar to class A. And as you can see here, I got another data type Y, integer private, and I have the constructors, I have destructors, and I have a print method. And I want you to pay attention to this print method, which is basically the same name as this one. And then I have another method, test class B, which is going to be print the B. After that, I got class C, which basically is very similar. Integer Z, constructor, destructors, print, and test class C. Now what I'm going to do, I'm going to come to the destructor, and I'm just going to put a cout method here. And I'm just going to say A and line. Of course, there's a reason why I'm doing this, and we'll talk about that in a sec. So let me copy this. I'll do the same thing for B, except that I'm going to put B here. And then I will put same thing for C, and I'll put C here. Okay. Now, how do we inherit? Let's imagine class A is my base class, and class B want to inherit from class A. The idea here is very simple. The syntax basically put a colon here after that, and then you type the specifier. And let me just continue, and I'll talk about the specifier in a sec. So I'll go public, for example, or private, and then you type the name of the class you want to inherit from, class underscore A. So this syntax is basically me inheriting from class A. Now I can come here and do this, public class underscore B. So basically, class C will inherit from class C is going to inherit from class B, and class A is inheriting from class A. This is like a chain. Or I can actually inherit, let's just imagine I didn't inherit from class A here. I can take that out, and I can put a comma here, and I say public class B. So you can inherit from multiple, wait a minute, he didn't like it for some reason. Yeah, and we are allowed to do that. And oh, sorry, look at this. This is class B. I was supposed to take this, my mouse, Control X, and I was supposed to put it here. Control V. And he didn't like it because we got double column. I should just stop and double copy paste. Okay, so here you go. I can have class C, which basically inheriting from two classes, which again, it's acceptable. Let's just go back to my original case where I do have this chain of inheritance. Now, what should we know about inheritance before I start running and trying to create objects? Rule number one, when you inherit from a class, you basically inherit everything you have defined in this class. So basically, B will inherit everything you have inside class A, except, this is very important to understand, if there is any, if there is again any friend method defined in class A, class B will not inherit it. And that makes sense because again, friend method to start with, they don't belong to a class. So if you have any friend method here, they're not going to be inherited. Let's just put it that way. And the other thing that you should understand, constructors and destructors are not going to be inherited from class A to class B. Same thing here. When C is going to inherit from B, everything you have here in B will be inherited to C. And since B is inheriting from A, so everything that was inherited from A inside B will inherited into C. Again, same rule. Constructors are not inherited, destructors are not inherited, and if there is any friend method, they will not be inherited. Now, if you go and search in the internet, you may see that some other references will tell you the operator overloading of the assignment operation will not be inherited. In reality, it is inherited, but the compiler basically is going to replace it with its own version of the operator overloading for that operation. So it's inherited, but when you try to have access to it, it's going to basically go and have access to the one that's going to be generated by the compiler instead of the one that has been created inside the drive class. This is just something to know. You could be asked that question in an interview or something. Okay. Now, since I know that everything here is going to be inherited into here, and everything we have here is going to be inherited here, and since B is inherited from A, so basically C will get everything in B and A. Now, what do we need to know about this operation? Oh, let me just ask this question. How about constructors? What's going to happen to constructors? Well, by default, when I'm going to create an object that belongs to class B, the default constructor of A is going to be called. And the same thing here, when I'm going to create a class object of class C, the default constructor of B is going to be called and of A is going to be called inside C. So whenever you create an object for the drive class, the default constructor for the base classes are going to be executed as well. And you should know also that it's not about that only. It's the order plays a major role. And usually, for example, let's say I'm going to create an object for class C. The first constructor is going to be called, I think it's going to be A, and then it's going to be B, and then the C is going to be called. Okay, now what if I don't want to use the default constructor? Well, you can use the member initialization list if you want, and that's still going to work with no problem. Now, we do have some issues, and we're going to talk about them in a sec, but let's just keep going here. So those are the rules. Again, the constructors are going to be called, the default constructor is going to be called, and if you want to call the argument constructor, then basically you need to go ahead and use the member initialization list, or if you have a setters and getters, go ahead and use them. Sorry, the setters, not the getters. Okay, so with that being said, whenever your program is going to be terminated, and let's say we have an object that belongs to a class C, the default the D structure of C is going to be called first, and then B, and then A. So the order is the opposite of the constructors when it comes to D structures. Now, one very important rule. What if I do have a method inside the base class, and I have the exact same method in the derived class? You see here, we got print inside class A, and I have print in class B. This is a case, it's called overriding the method. What does that mean? It basically means if I take this away, when I create an object that belongs to a class B, this method is going to be executed. But, sorry, my bad. If I, because I commented, they basically mean it's this method doesn't exist. So if I go to class B object and I call the print method, basically the one that I inherited from A is going to be executed. But since I have this method here, and I'm trying to inherit from A, and because of the similarity between those two methods, same return data type, same name, same arguments, if that's the case, then the implementation will be done using the derived class. Now, let me give you an idea about this so you'll understand what I'm saying here. Let's go back to the zoo example. In the zoo example, I had a method called breathe or move. Let's go back to the move method. Now, inside that zoo project, inside the base class, we have a method called move, and we have three classes. We have the cat, we have the dog, and we have the fish. Now, I can inherit the move function from the animal class if the move mechanism basically was built based on having those uh, how dogs and cat move usually, using the two legs, and I don't know what they call them. They have all legs anyway. So that's basically how the dogs and cats move. But let's talk about fishes. Fishes basically they don't use the same mechanism in movement. So if I'm going to inherit from the animal class, obviously I have something that doesn't make any sense. So what I need to do inside the fish class, I need to have the exact same method name with the same return data type and just change the implementation. And that's basically what we mean by overriding. So this case here is overriding for the method that I inherited from this, and this overriding the method that I'm inheriting from this one. That's something to understand. Okay, now the most important question that you have to ask yourself is, how about private elements and public elements here? When I'm going to inherit them, what's going to happen to them? And most importantly, what is this keyword here, public and public? Well, to answer this question, I do have a table, and this table is extremely important to understand. And I'm going to go through I'm going to use my example, and I'm going to use this table here to explain what do we mean by that. So this column here is telling you that if I have a base class, and inside this base class I have public elements, I have protected elements, which is something new, and we have private elements. Let's focus on the public and private, and then I'll get to the protected elements. So if I inherited from a base class using a public specifier, just like I did here, by typing public here and typing public here, what's going to happen? Let's just go back to the image. If the element was public, then it's going to be inherited as public in the drive class. If the element was protected, and I'm going to explain what protected in a sec, it's going to be inherited as protected. Now, if the element was private, then basically it's going to be, here, let me just explain what do I mean by not accessible or hidden. It's part of the class, the drive class, but you don't have access to it. That's basically what it is. So what does that mean? Basically, let's go back here. Why do I keep minimizing? Okay, so this, for example, class B is inheriting from class A, and in class A, I do have the variable x. Now, inside class B, if I try to have access to x, I will get an error and telling me that x is invisible. I don't have access to it because it's private. But again, does that mean x doesn't belong to class B? No, x is a part of class B. It just happens that class B cannot change it, cannot modify it, cannot have access to it because it has been defined here as a private. Okay, same thing here. I'm inheriting from class B, and in class B I have a private element y. If I come here, for example, and I try to change the value of y at any function here, it will tell me you're not allowed to do that because y is a private. I cannot change it. And that's, again, how important to understand this concept. So let's go back to the table. If I'm going to inherit and I'm going to go and use specifier to be public, then everything that's public is going to be inherited as public. Everything that's protected is going to be inherited as protected. If it's private, then you're inherited, but you don't have access to it. And that is applied to all the private elements, whether you're going with public, protected, or private. Now, if you inherited private, basically all the public and protected elements that you're going to inherit are going to be turned to be private in the drive class. So what does that mean? That basically means if I go here and change this to be private, so when I'm going to inherit, let's say, this method, which was public, but when it's going to get to the class B, it's not going to be public anymore, it's going to be actually private. So that's something to understand. So let's go public. Usually we inherit as public. Let's just put it that way. Or protected. Now the protected. What does the protected mean? Well, protected basically it's something between public and private. It's exactly between them. What does that mean? It basically means when you have an element that is protected, it means outside of the function you cannot have access to it. So it's acting like private. But if it's defined as protected and you try to inherit it, well, it's going to act as public and you have access to it. So what does that mean? Okay, let's go back here. You see this private section here, this private element and this private element here. Now let's go ahead and change this to be protected. What is, okay, you, again, this is Visual Studio, okay, go, yeah. I hate Visual Studio for this. It takes him a while to realize that I didn't do anything wrong, and that basically get me to start questioning myself. Anyway, so look at this. We got protected here, and I'm inherited it as public. So when I'm going to inherit this protected from class A to class B as a public is going to be inherited as protected. So basically that means I can have access to it here. Like for example, if I want to come here and change the value of X inside the class of B, I can do that. But again, if I try to change the value of X inside the main function from an object that belongs to a class B or A for that matter, I'm not allowed to do that. So when I defined X here as a protected and I inherited from A, now I have access to X inside my class B. So it's acting as if it's public, or sorry, it's acting as it's private. I do have access to it here. It's not private anymore. I can change it, I can modify it, I can do whatever I want to do with it as long as I am inside the function here. But if I try to have access to it here, I'm not allowed to do that anymore. And that's basically what protected is all about. So whenever you actually do inheritance, it's recommended to declare whatever was private to be protected. So basically the elements here will be able to have access to them with no problems. Because again, you're inheriting the value of X, so probably you want to use it. So keeping it private here basically means you will not be able to use it inside the classes that you're inheriting to. Okay, so here we go. Those are the details of inheritance, and this is basically how it works. And let's go ahead and try to play with those functions that I just created here. Okay, so if I can create a class A object here inside the main function, and let's go here, class underscore A, I will say obj A. I'm not going to call the constructor. I'm just going to keep it simple, and then I'm going to call the other constructor. Let's go ahead and do that. And let's call this one A2, A1, A2. Let's pass 19 here. And then I could come here and say obj1 dot print. And then I'll do the same thing for Control C. Control C. Let's just go ahead and do that. This is for 2. And for the other one, I don't really have to call them for both. I'm just going to go with one of them, which is, I think, test class A. And let's run it. And I think I made a mistake. It's not a mistake, but I need to have a screen holder at a certain point. Oh, come on. Okay, let's close this. And here we go. Let's increase the font size. 019 test class A, and I'm done. Let me just have a screen holder at the constructor here, destructure, get character. Do I need a get character? Yes. Press enter is going to be acceptable. Let's just copy this and keep it everywhere. Let's just put, where's the destructure? Here it is for the B. No. Look at this. What? There we go. Oh God, what's going on here? Okay, let's go back. Same thing for C. What I'm going to do, I am going to take this, well, you'll just keep it as it is. Now, let's go ahead and run it again. I hope it doesn't take as long as it takes the first time. Nope. Okay. And look what I'm going to do here. Click here, A, and I'm done. This is basically calling those constructors. Now what I'm going to do, let me take this away. I don't need that anymore. Let me take this away. And let's create an object that belongs to the class B. So class underscore B, OBGB, and let's call the default constructor first. And let's go ahead and say OBGB.print. And let's go ahead and do the OBG, look at this, dot test. Look what I said. When I type test, it showed me both of them. So I can call both of them if I want. Test A, and then I'll do the same thing for test B, OBGB.test class B. And here we go. So let's run this just for the purpose of running. And let's close this. And as you can see here, I got class A, this is class A, and I got class B with y equals 0, and test class B and test class B, A and B. Now look at this, B and then A. So the order of the destructors here. And then I got A again, because for this class. So I got B, destructor of this one, and since B is inheriting from A, so I had to call the destructor of A, and then since I have an object of A, I'm going to call the destructor of A again. Now, this, as you can see here, this worked perfectly fine for printing printing the Y value. But what if I want to see the value of X printed here? Well, let me just show you what I'm going to do. If I come here and type this, you know what? I think I can actually call it here by typing class A, print, put semicolon. Let me just try that. I am not 100% sure that this will work, but let's just give this a try. It actually worked. Okay, look at this, what just happened here. This is object A, and then I created object B, and look, I asked to print the value of X. As you can see here, I got X be printed. This is one way to get the job done, and of course now the destructors are going to be called. This is again one way to do that, by calling that print function and by using the class name. It looks like it's a static, but it's not actually static. Or let me just comment this section, and I can come here and look what I'm going to try to do. Let me go back and put this as private, just to show you the importance, okay, of having that element to be private. So if I come here and do this, cout, and I'll just go ahead and say class underscore A. Well, you know what? I don't want to do class underscore A. I will just come here and just add X equal X, and put an end line here. Immediately you get the error here. Why is that? It's inaccessible. Why? Because it's defined here as a private. So as you can see here, class B is inheriting from class A. A have a data member which is X, so I'm inheriting it, but I don't have access to it. X is it's a part of class B, but I don't have access to it even inside class B because it's basically private. Of course, that's going to be the same case if I try to change it here in the main function. But if I come here, let's just go back here and change this to be protected, you would notice that, okay, just give Visual Studio its sweet time. Okay, keep going, keep going. Here we go. Now, if I go back, now it's gone. I can have access to it. So basically, I can call the function if I want, but if I have that element defined as protected, I will have access to it directly here. Now, let me just show you what does that mean. If I come here and do this objb.x equal 100, you'll notice that I'll get an error here, and it's inaccessible. You can't have access to it. And that's, again, the beauty of it. Inside the class itself, because I'm inherited it here and it was protected, so public is going to be inherited as protected. So basically, I do have access to it here with no problems. So it's acting as if it's public. But when I try to have access to it here from the main function, it's going to be actually asking as if it's private. And that's basically what protected is all about. Okay, let me run it again. And let's see here. And here it is. Y equals 0 and x equal 0. This is test class A, this is test class B. Okay, let me just fix this by adding some sort of space here. Okay, so here we go. This is the inheritance, and this is basically how it works. This is me overriding the function print, and I do have access to that function, which is test class A and test class B here with no problems. Now, what if I don't want to call the default constructors? Okay, while you're complaining here, again, I'm going to come here and type 19. And here, I'm going to type 200. Okay, now immediately you see here, we got an error. Oh, not here, sorry. 200. Okay, remember this object here doesn't have to do anything with the object that I have here. So I am just going to comment this section. And let's go ahead and run it. And you will notice what is the value of x that's going to be printed here. It's going to be 0. Why is it 0? Because the default constructor was called. So again, what if I don't want that to happen for a class here? Well, I can do this. I can come here and type x, and I'll come here and type x, and I just have to pass x here. So I'll just go ahead and put 89. And remember, because it's protected, I do have access to it with no problems. Let's just go ahead and run it. Well, actually, what's going on here? No overloading function. That's 2 arguments. Well, is it? Oh, integer. Let's run it again. Oopsie daisy. Main function. X is not base member. Where is that? He doesn't like what I'm doing here. Even though it's protected. Integer x. Okay. So how do I change the value of x if I want to? I cannot. Oh, because it's not defined here as a part of the class B, so you cannot use it this way. If this is the case, let me just try and see if I can come here and type this x equal x semicolon. Now let's run it. And actually this time it worked. Okay, I thought that the member initialization list will go over this, but again, I was not able to do that using member initialization list. And at the same time, let me just show you. If I come here and change this to be public, private, we will get an error here. You don't have access to it. So this is why protected. You have to have it as protected if you want to manipulate that variable inside your function. Okay, so here we go. What I'm going to do, I'm going to take this away, and I'm going to take this away, and I'm going to come here to the class of C, and I am going to actually pass integer y and integer x. And in this area, just like we did before, let me copy it from here, put it here, and then put it here. So we'll go with x and y. And I'll just put y here. So we set up those y's. Let's see here. This is the constructor, destructor, and let's try to print the values just like we did here. So I'm going to copy this. Oh, you know what? I don't need to copy it. Yeah, let's just add to it. So I'll put y here, and I'll put x here. And in this area, I'll just put space y equal, and this area space x equal. And now instead of having object B, let's have object C. And instead of passing 2 values, let's pass 3 values. And this is going to be object C, and this is going to be C, and this is going to be C, and I can actually have access to C itself. And of course, I need to take this B away. Well, there's something he doesn't like here. Let's say integer x. Let's try it. Oh, of course, this has to be changed to be C. Okay, now let's give this a try. And here we go. As you can see here, Z200, Y89, and X90 is class A, class B, class C. And look what's going to happen when oh, my bad. I put that get character in the wrong place. I was supposed to hold the A, which is this one. I'm just trying to show you the order of which destructor is going to be called before the other one. So give this a try again. And here we go. Press it, CBA. And that's basically what constructors are all about. Sorry, that's what the inheritance is all about. This example here, just for demonstration purpose, in reality, they're a little bit more complicated than they look more complicated, but the idea is exactly the same. In C++, you are allowed to inherit from multiple classes, unlike Java, where you can only inherit from one class. Understanding inheritance is extremely important for the next class, which is going to be called polymorphism. And let me just tell you this from now. If you're going to apply for a job in the future, I will guarantee that you will be asked about polymorphism a lot. And to be able to explain and understand what is polymorphism without understanding what's inheritance, then basically there is no way you can understand polymorphism. This here, the example that I'm showing here is just to demonstrate the concept. Those objects or classes that I'm creating, they don't make any sense, and I understand that. But again, I'm not here to make a class that makes sense. I'm just trying to demonstrate the concept. In the lab, in the exercises, basically, yes, you're going to have to use those concepts to get something that makes sense done. I am done for today, and I'll see you guys later.